Happy Snow Day, students. Today, what you're going to be doing is, of course, this is right on the calendar. It shows the expectations. You're going to be working with your lab partners to complete the Planetary Motion Lab and also this new lab, the Universal Gravitation Lab. All these materials are in your packet. So here's the link to the packet. Once you get that done, it doesn't take very long to do those labs. Remember, the Planetary Motion Lab was your homework for last night, so you really should have that done already. But the Universal Gravitation Lab is new for today, and that shouldn't take very long. If you get those done, I highly suggest that you try these problems on worksheet 4 and worksheet 5. You won't be able to do worksheet 3 yet because universal gravitation is covered on that worksheet. We haven't talked about it yet. You want to make sure you have both those labs done. You've got all the data gathered, you've got it graphed, you got it linearized, you know what the mathematical models are, because I'm going to be grading you on how quickly you can put together your whiteboards and how well they look. So right here are the grading criteria. If you have nothing on your whiteboards or if you just slopped it on there, you're going to get a low score. Okay. If you get all that stuff done, remember we also have to make up all those other snow days, and here's the e-learning material I've already kind of talked to you about. So here's the two links, and there's calendars on there so you can try to plan it out. I highly suggest you check those out. Okay, so now let's look at the Universal Gravitation Lab. So I would go to my packet to look in there. Oh, this is the Planetary Motion Lab. Don't forget to do that one. Right there's the link. And I'll also have a video, if you weren't here yesterday, a video of how you would go about getting the data on yesterday's assignment calendar if you look at that. Okay, so now let's look at the Universal Gravitation Lab. In the Universal Gravitation Lab, when you start this simulation, again, here's the URL, you're going to see these two stick figures with these big massive spheres that they're going to be able, you can move toward one another, and you'll be able to read the forces on them. So your goal in this lab is to graphically and mathematically model the relationship between the force of gravity between these two objects and the distance between their centers and the mass of one object and then finally the mass of the other object. So there's going to be three sets of data you're getting. Okay, so this is what the lab then looks like when you get to it. Okay, so this lab, when you get to it, this is what it looks like, and you'll be able to change where these people are, and so you can move this meter stick and you can measure the distance between their centers. Of course, you need 6 data points. You need to keep the masses constant. You can't go changing them, and so you'll just simply get your 6 data points and you'll record the force. Notice the forces here are the same, but they're in opposite directions. You should think about why that is. Okay. And you can see the forces getting less as you move further and further away. So make sure you get 6 data points for this. So it's going to be that force compared to the distance away. And then for the next one, you're going to figure out the force, and you don't really care about the distance away other than keeping it constant. Let's say it's 4 meters or whatever. And you're going to be changing the mass to whatever you want. Let's say mass 1, you'll be able to change that to whatever you want it to be, and you'll see the effects on the force. And again, you need 6 data points. And then you'll set this mass to whatever you want it and leave it alone for the third part of the lab, and you're going to be changing the mass of the other one, again making sure the distance is fixed. So it should be pretty easy to get your 6 data points for each of the 3 sections of this lab and then to graph them. It's going to be force versus distance, force versus mass 1, and then force versus mass 2.